Hello, this video is the introduction to derivatives or also differentiation. So I used kind of these two words almost as synonyms, not necessarily like exactly synonyms, but words with very similar meanings because differentiation is to find the derivative of a function. So that's why they mean basically the same thing. But one is actually the act of finding the derivative, and the other one is the derivative itself. So now, okay, so the definition of a derivative is the slope of a tangent line of a function. But there are some words that maybe you are not very familiar with. So for example, well, the slope I know you're familiar with, but just as a reminder, it's the change in y over the change in x. So the change in y can be thought of as the change in f of x, the change in as you traverse along the function, the change in the result. And then also the tangent. So a tangent line is a line that touches a function, the graph of a function, in only one point. So, as you might recall, when you have, for example, a circle, you have your secant line, I believe, which touch the circle in, like cross the circle, touch it in 2 points, and then you have your tangent line, which barely touch the circle once. So it's the same idea with a function. So let's say that you have your x and y axis here, and you have your function that maybe looks something like this. And a tangent line would be a line that touches the graph at one point and just continues. So for example, here you see that the tangent line actually crosses this point right here, even though I said that a tangent line only touches the graph once, but that is not relevant because when you're trying to see the tangent at this point right here, what you wanted to do is touch that point and continue without touching any of the adjacent points or close by. This is just an inconvenience. But yeah, so let's see. So why is finding a derivative so important? Well, because it's not that easy. So let's say that you have this graph and you had this function like this. So if you're trying to find the tangent right here, how will you find it? It's just at this, like at a point, the exact point. It's not 0.0001 more or less. So how can you find exactly the line that touches the graph right there and doesn't touch anywhere else? Well, that is hard to find. So what we do is first find a secant line. So for example, this one that actually crosses the graph in 2 points, but as you start to make the change in x, so this is our change in x right here and right here, smaller and smaller, you will eventually reach this point. So we make it smaller by taking it closer to the point, moving it closer to the point, and as you can see, delta x has gotten smaller every time up to the point where actually we want delta x to be 0, like to be almost nothing. So this is a very small delta x, and we just want to reach 1 point. So that's when alpha x is equal to 0. And that is the definition of a derivative. So, just putting what I just said from words into real math, what we want to do is that the derivative if we were to annotate it like this, so you will see that most of the times instead of saying derivative or anything, you see f prime of x. So that means the derivative of f of x. So the derivative of f of x is a change in y over a change in x as the change in y and the change in x, the limit as it approaches 0. So when the change is 0. Of course, as I said before, you can think of y as being f of x right here. And so actually, if we want f of x1, for example, where x1 is just x, we get that y is equal to f of x. And if we say that x2 is x plus some change in x, so that is this right here. As you can see, here we have x1, then we add that small change, and we get x2. So it's x1 plus some delta x. So f of x2 is equal to y2 and we see that also going from y1 to y2, our delta y is just their difference, so y2 minus y1. So keep that in mind. And so if we define y2 to be f of x2, we can just rewrite this with these equalities right here to be f of x plus delta x. And so what, as we mentioned, the change in y is just f of x plus delta y. Delta x minus f of x. Delta x, we can just write delta x. So we just rewrote this function as also the limit, but now it all only depends on delta x of f of x plus delta x minus f of x over delta x. And this is the formal definition of what a derivative is. Not in words, but in just variables.